In this chapter, we will be looking at how to secure a REST-based web service. Well, actually everything we do here would also be applicable to SOAP, but we are going to be using REST for the example. If you're on this course for the OAuth, then please don't skip this chapter. There are a few techniques in here that we are going to be carrying forward into the OAuth section. So coming up in this chapter, we will use basic authentication to secure the service, and don't be fooled by basic, it's perfectly production standard. We'll see how to send basic credentials, which is an odd process using base64 encoding, and the last 15 minutes will be on how to make our REST service truly stateless. But actually, if you think about it, in a way, we already do have some security applied to this REST-based web service. Have a look inside the CRM security config.xml file and be careful that you choose the right one, because of course we also have a security file for MailMonkey. We're not working on that here, so I'm going to make sure that that is closed. Well, we have in our security configuration a setup where all URL patterns, regardless of what they are secured using form-based authentication. So this is going to apply not just to the website, it will also apply to our REST services as well. Went through this quite quickly in the previous chapter, but if I go back to the website and log out, and without logging in, I now try to access the REST service again. So I'll try that customers URL pattern. Well, I am taken straight to the login page. If I log in here, then the REST service is responding. The problem is form authentication is not useful for securing a web service. The first reason, probably the big reason, is that, of course, our clients are not likely to be using browsers, where the end user is just entering a URL into a browser like we're doing here. It depends on the service as to what the format of the clients are going to be, but in general, a REST client is going to be some kind of standalone application. Just think of it as a machine. So our client could be an Android client, or it could be an iOS client. It could be a standalone application written as a desktop app, or it could be, and this is where we'll be going on this course, it could be another website that is invoking this URL in its internal code. So the users aren't seeing the call to the REST service, it's being done by program code. On the original Spring Remoting course, we simulated this situation using this third project that we have here, which is called the REST client. And I have refactored this slightly from the original version. I've put all of the classes into their own packages. So we have a package containing just the exceptions. We have a package containing the resources. That's just the classes representing the data types. And the important class is the REST client.java. So you can think of this as just being a standalone client application. And as we did on the Spring Remoting course, we're using the class called the REST template. That's a helper class supplied by Spring to make it easy to call REST web services. And really the important line of code is here on line 20, where we're making a GET request to pretty much the same URL pattern that you saw in the browser. Slight differences, we're supplying parameters. We're just saying we want the first 2 customers to be returned. Now, unfortunately, I think if we try to run this as a Java application, now the exception, if we have a look into the details of the exception, just moving across to the right a little bit, the exception is complaining that the content type that was returned was text/HTML. And really, the exception is saying, it's coming from the REST template. The exception is saying, I have been given HTML in response to the request, which is not what we're expecting. Of course, a REST web service should be returning something like XML or JSON or some other structured data format. We should not be getting HTML, and the template simply can't handle it. Why are we getting HTML? Well, because we're using form-based authentication. Clearly, this standalone client simply cannot work with a form as a response to a REST request. When we get to the OAuth section of this course, we'll find that there is a way of using OAuth to enable us to authenticate securely with the REST web service. And that's quite a good solution, but OAuth is quite complicated. And before we get there, there is a much easier way to secure a REST web service, and that's using our old friend, basic authentication. We covered basic authentication back on the first module of this course. That's authentication where there is no form. If you use basic authentication on our website, then we would get the very basic and ugly dialog box. Just to remind you of that, let's go into the CRM security and we can comment out the form login tag, and we'll need to make that comment also include the logout tag as well. And we'll replace that with the, recall this from the previous module, with the HTTP basic tag. You don't need any parameters into that tag. Let's redeploy the whole site. And just in case you're new to Virtual Pair Programmers courses, once the build script is run, you will need to wait about 2 seconds for Tomcat to pick up the change. So don't be too impatient going straight to the web page. That can cause problems. Now we'll try to go again to the website/allcustomers.html page. And now we're getting, instead of the form, the basic authentication box. Now, of course, this is absolutely awful for our website, but it turns out that basic authentication is perfectly usable for machine-based clients. So I'm not even going to bother logging in there. If we go back to the Spring config, the security config, I will undo the changes made. So we've got the form login back again. But of course, what we can do in here is we can supply multiple HTTP settings. I'm going to add a block. Importantly, this is going to come before the other HTTP block, because this is going to be the settings for our REST service. And you can probably tell now why I've gone to the effort of changing the URL patterns, just to make it easier to trap in here. I can say if we have the HTTP pattern beginning with /rest and then anything else to follow, we can supply in here a specific set of rules. We can say that if we've intercepted the URL, again, the pattern will be the same, anything beginning with /rest, we are going to insist that the user, whoever they are, has the role of a CRM user. Now, we could, if we wanted here, define a new set of roles specifically for web service clients. I'm not going to bother here, but that would be a very easy job to do, and we will be doing that kind of thing when we bring OAuth into the picture. But that's really all we need for the intercepting. That's going to catch everything on the web service, and we can include the HTTP basic tag. So I hope this makes sense. It's quite simple. Spring will check this first, and if it matches this pattern, it will apply basic authentication. If it doesn't match this pattern, it will fall through and it will be caught by this pattern here. That's why the ordering here is really important. So we'll redeploy. And the first thing that we want to check is that the regular website is still intact. So I'll resubmit that URL, and great, we're back to the form-based authentication, and that looks like it's working okay. But now if I log out and now I attempt to access the REST URL, then we should see, yeah, we're now being asked for basic authentication. So this is now the valid username and password. So the reason for using basic authentication here is that it's easy for standalone clients to send that authentication. Let's go across to our REST client. And okay, we haven't added any usernames or passwords here yet, but let's see if there's a difference when we run the code. Now, this might not look like a big difference, but it is. If you can remember back to when we ran it previously, the exception was complaining that the content type was text HTML, and the REST client simply couldn't deal with it. But this time, we're actually getting, this is one of our exceptions that we wrote on the previous course. It's the unknown HTTP error exception. Now, if you want full details of this, you will have to review the chapter on the Spring Remoting course where we handled custom exceptions. But very briefly, what's happening is we have a special class here called the Custom Exception Handler. It's very carefully checking the response code that has been returned by the server. And depending on the type, it's throwing a specific exception. Now, the response code we're getting back is going to be one of the 400s. And it's going to be something like authentication required, but we're not currently handling that here. Now, we could go ahead and create some extra exceptions, but I don't want to waste time on that on this course. So I think I'm going to do this very simply. We'll just upgrade the unknown HTTP error exception a little bit. We're going to pass in the responses status code into the constructor of that exception. And then I'm going to use the quick fix here and just left click on the error there. And I'm going to select the create constructor option. And that's going to very quickly add in a custom constructor into this exception. And what we'll do is we will store away that status code into an attribute. Now, I haven't defined that yet. So again, I think I'll use the quick fix here to create that field. And the point of doing that is we can interrogate this status code when we're getting the exception. There's lots of ways we can do this, but I think I will just do a source, generate getters and setters, and I'm going to generate a get status code method. And then in the REST client, we can do something with that. So again, I'm not going to do very elegant code here. The point is just to prove that this works. I think I'll just add a try catch block and we'll catch this unknown HTTP error exception. And then we can get that status code. And the status code is an object supplied by Spring. We can call the value method to get the HTTP status. And this get reason phrase looks quite useful as well. So I think we'll call value and then e.getStatusCode.getReasonPhrase. So that's very much better than we had before. If I run this again now, that's absolutely perfect. We have HTTP status 401, which simply means we're unauthorized. And there's no surprise really, because we haven't attempted to send a username and password. So it's good that we are getting a correct status code and we're not authorized, but obviously we need to know how to authenticate ourselves. And it turns out that in basic authentication, perhaps as the phrase suggests, basic authentication is quite easy to send our credentials. The specification for basic authentication tells us that in order to send our credentials, we simply have to add a request header. And I'm sure you already know, but the request header is just a collection of key value pairs. That is, if you like, extra information about the request. It isn't usually seen by any users if you're working in a browser. And when we're working with a REST web service, it's just used to send any extra information. And the key value pair that we need to send credentials is the header name, the key is authorization, and the value is this rather strange looking construct. It's the standard string of basic with a capital B, and then following a space, this collection of letters. Well, the collection of letters will be different depending on the username and password. But in fact, all you're seeing here, this collection of letters, is the username and password separated by a colon run through the base64 algorithm. You might be familiar with base64 already. Here's the Wikipedia page for it. It is an algorithm that converts binary data into an ASCII string. This might look really strange because, of course, this here, our username and password, isn't really a binary data. It is a string. But the reason that the specification asks us to do that is just in case there are any characters inside the username and password that HTTP can't handle. It's just, if you like, a way of making the characters safe to send across the HTTP protocol. Let me be very clear about this. It is a common misconception. This is not encrypting the username or password. It is trivially easy. If a hacker was able to intercept our request, they could very easily take this apparently random jumble of characters and work backwards to get back the original username and password. So for that reason, it's going to be absolutely essential that all of our REST web service calls are made using SSL or TLS, which we described in brief in the first module of this course. And what we're going to do is we're going to add TLS to our system right at the end of this module. Although it's essential that we have TLS, it will get in the way of development. So we're going to develop without it, but you must remember that none of this is secure until we apply TLS. So what we need to do in our client then is add a request header containing this data. That does mean that our REST client is going to get a little bit ugly. There's going to be a lot of code here to achieve this. But in real life, you would probably factor this away into some kind of utility method. What we need to do then is to take the string, which is going to be the username followed by a colon, followed by a password, and we need to convert that into base64. So I'll call this the original user pass. So how do we encode using this base64 algorithm? Well, there are a lot of implementations of base64 out there, and it turns out that from Java 8 onwards, there is a class in the API called base64. If I do a control or command space, just after typing the class, here are all of the versions of base64 that are on our class path. And I'm going to highlight this one here, which is the java.util version. But as I say, that's only been there since Java 8, and I don't know if you're on Java 8, but it doesn't matter, because there's another version here, which is the Apache Commons Codec version. You're probably familiar with the Apache Commons library and Codec. I just checked this out in our lib directory. Commons Codec has been a jar file that we've had in these projects forever. It's probably used by some part of Spring or Hibernate. That's why we needed it there. But that's great because we can jump off the back of it now. So I recommend you use this one as well, just so your code is the same as me. So make sure you've imported Apache Commons Codec. And that has a collection of static methods, one of which is encode base64. If you did want to use the Java 8 version, then the method is called encode, but otherwise the details are the same. All we have to do in here is pass in the binary data that we want to encode. Well, a string isn't binary data, but we can always call the getBytes method to convert it into an array of bytes, which is exactly what that method needs. The encode base64 method is going to return a byte array. Now we really want a string, so I'm going to call this string the encoded data. But again, I don't know if you know, there is in the string constructor, the string constructor will perfectly well accept an array of bytes. So that's all we need to do this encoding. And it's not going to work yet because I haven't done anything with the data, but just for a test, I'll output the encoded data to the console. And there you can see the very strange collection of letters that is the base64 encoding. So that's the first step. The next step is we need to include this in a request header. Now this will be some work because the Spring REST template you've got to work quite hard with in order to set request headers. And the way to do it, it's fairly routine really if you just follow along with me. We're going to create an instance of a class called HTTP headers. We did do this on the Spring Remoting course, but it's the kind of sort of very boring routine work that it's very easy to forget about. So we just need to instantiate that object. We'll do an import, and this is important. It must come from the org Spring Framework version. And then we're going to do a headers dot, and we just do an add. Now, as I said on the caption, the key for this is authorization. And make sure you spell that with a Z or a Z. Some parts of the world use an S there. You do not need the colon here because the colon is kind of implicit. For the value, again, as on the caption, it's a standard string which is basic, that is case sensitive, followed by a space, and then we add on the encoded data that we had in the previous step. Okay, well that sets up the headers, but now we need to create the HTTP request itself. And we do that by creating an instance of the HTTP entity class. This is a generic, so we will need the angle brackets, and this is going to contain the class name of the data type that we're expecting to receive back in return. So if you haven't been on the remoting course, and you won't know that the object that we're getting back from this request is a class that we've written called Customer Collection Representation. Just contains details of all the customers. So we need that to be in the angle brackets. I'm going to call this object request, and this is just a new HTTP entity. Again, we need the generic in the angle brackets, and we pass into the constructor here the headers. HTTP entity will need to be imported, and again, it will come from Spring. So that's the sort of background work done. All that remains now is we need to pass this request into our get. Unfortunately, and you can check this in the Java docs, the implementations of get for object don't accept the request. Instead, we've got to use the method called exchange. Now, I did cover this in the Spring Remoting course, and I just think of this method as being a you can do anything you like with the REST template. It is a bit harder to work with. I think I'm going to sketch out this code on the next line and then get rid of the previous line. So the method is exchange, and this is going to take 4 parameters. The first one's easy. That's the URL that we're sending the get to. So that will be the same as it was before. The method is whether it's a get, a post, a delete, or whatever. So this is HTTP method dot get. The request entity is the object that we just created in the previous step. That's the request. And the response type is, again, this class here that we're expecting to receive back in response. This will need to be dot class. Well, I never much like working with that exchange method because you do have to do a lot more work, and it's also slightly harder work to deal with the return value. So our previous version, we just got back a raw customer collection representation, the object that we want to work with. But in this version, we'll get a bigger object in return, and it's called the response entity. I think I'll call this response. That will need to be imported. That imported automatically, but it does come from Spring, as you can see up here. Now, this is a generic class, and the generic, once again, is just the type of data that you're expecting inside that response. So now that we've got that in place, we can delete the old version of that, where we were not sending the request, and now we're finally done. This is going to send the full authentication details, and it's going to send us back an object which contains things such as the response code and a few other things. But what we really want is that customer collection representation, and that's very easy to get hold of now. And we're calling this all customers. We just extract that from the response. There's a method in there, getBody, which gives us exactly what we need. So it's definitely harder work than we had before, but I can easily leave it to you to use your standard Java coding skills to extract that maybe into some kind of utility or helper method. The important thing is, does it work? Let's give this a try. And certainly no exceptions there. And this is exactly what we want to see. This is giving us a list of customers. Now, the string implementations of these representations are to output the customer ID and the customer name. And I don't know if you noticed in the original URL here, we were just asking for the first and second customers in the system. Part of our REST implementation is that it also sends you a link, and that link is giving you the URL of the next page of customers. So we could play around with that. We could copy that link into the exchange method. Of course, in real life, this is the sort of thing your application would be doing automatically. That should give us a longer list of customers, and it does. That's looking good. What happens if the username and password is not correct? And we get the status code again of 401 unauthorized. So using basic authentication is a perfectly respectable way of working. I think some people think that basic authentication is something that you would never want to use in practice, but that's true on customer-facing websites, perhaps. But for client applications, there's no problem with basic authentication, except for the fact that this username and password are being transmitted in what is effectively plain text. So we would absolutely have to use transport layer security in order to make this secure. As I said, we're not going to do that right now, but we will do that towards the end of this course. There are some alternative authentication schemes which don't need to use TLS. One example is digest authentication. But my feeling is that digest authentication doesn't seem to be used very often these days, probably just for the reason that it's a bit more complicated. It doesn't really give you anything that basic authentication with TLS, otherwise known as SSL, would give you. So that's how you might secure a REST or a SOAP-based service. In the SOAP-based service, you would just be securing the address that you're posting your SOAP messages to. There really isn't anything particularly complicated in here. There is one last thing that I would like to discuss about basic authentication. Now, I think this is a little bit of perhaps a pedantic point, but if you're still with me, it's quite an interesting discussion, this. I know that earlier on in this chapter, I hinted that form-based authentication is not the right thing to use for a web service for one big reason, which, as we've seen, is that our clients simply can't work with forms. But I was implying that there were other reasons. And the other reason for me would be that REST is intended to be stateless. And by that, I mean with a REST service, we shouldn't have a session. That's part of the philosophy of REST. If the server needs to maintain session state for every client, then the server becomes unscalable. The Wikipedia page here for REST has a header of stateless. Do study this for yourself if you're interested, but it's saying that there is no client context being stored on the server between requests. So this is another reason that form-based authentication would not work. In form-based authentication, we send the username and password once. That's when the user's filled in the login form and they've clicked submit. But then the server maintains the credentials for that user in the session state stored on the server. Therefore, all future requests don't need to send the username and password. That's for form-based authentication. But for a REST web service, we do not want any state to be stored on the server. And that's another reason why basic authentication is the right choice. Because in basic authentication, we can send this header with every single request that we make. That might seem tedious, but it's actually perfectly routine. We would just make sure that every call we made included that header. Now, I'm going to demonstrate this over the next 10 minutes or so, but I must admit there's something coming up that caused me a lot of pain while rehearsing for this, and it took me a long time to work out what was going on. And it's certainly the case that with these complicated frameworks and complicated mechanisms like REST, there are always things that can take you by surprise. Let me demonstrate by reverting my password back to the correct one. So our client should be working. So we're getting back a set of customers. Now, my contention is that if we were to make a second REST request, so we'll do this at the end of our try block. And this time I am not going to send the username and password. So I'm just going to use the templates get for objects, for example, and that's where we just have to pass in a URI. I'll do the exact same call that we did previously. And we're expecting back the response type, which is that customer collection representation. Now, normally, of course, I would store the results in an object and print it out, but really all I'm interested in here is, does this call succeed? You might want to think about whether it should succeed or not before I give this code a run. Well, I'll tell you in advance that this code should fail. I'll comment that. And it should fail because we're using a REST service. And as I have stated, REST web services should not maintain state between the client and the server. So when we make this request, the server will not know or care that we've previously made a request with the username and password. So in other words, this request should be being made with no username and password. Well, I say should, but to my absolute amazement in rehearsals, if we give this a run, well, I'm not printing anything out for the second call, but you can see there is no exception. Now, I found this absolutely baffling because the only way that this could be working is if somehow the server is maintaining a session. And the only way a server can maintain a session is by the client storing a cookie. And the cookie would contain a key, the session ID. If you don't understand any of that, then we did cover this on our Java web development course. For a session to work, the client needs to store a cookie with a session ID called the JSession ID. But the REST template is designed to be stateless. And so I do not expect the REST template to be ever storing cookies or sending the JSession ID. but it must be somehow the server is remembering that we're logged in. Well, in rehearsals, I decided to go into the implementation of the web service. This is let's close a few of these down. This is the customer REST controller here. And I decided that in the method here, I'm going to print out the request headers just to see what the incoming headers were. Now, if you want to do that, you don't necessarily need to follow along here because this is just for information. But I don't know if you know this, but in Spring MVC, you are allowed to create a private instance of the HTTP servlet request, which I'm going to call request, and you can auto wire that in. And that's, we'll need to import auto wire, but that's going to, or auto wired rather, that is going to give us low-level access to the incoming request. And I must admit, this is going to be quite painful because the HTTP servlet request is from the servlet API and it's very old and it's not very well designed. I can call the get header names method, but unfortunately this returns an object of type enumeration, which is a very old class that came from the first version of Java. This was replaced by iterators. So you very rarely see enumeration used in modern code. And it's really awkward to work with. You have to, and as I say, you don't need to follow along here. This is just for the demonstration. You have to call the has more elements method on it. And then inside the loop, we can call the next element method, which will give us the name of a header. I'll call that next name. We'll either have to do a class cast there, or for ease, I will just call to string there. Then what I can do is I can call the request object again, but this time I can call get header, and this one asks me to pass in the name of the header. And this is going to give me the value for that header. So all I'm trying to do here is I'm just trying to do a system out print line. I'll just print this out to the Tomcat console, and we'll do the name followed by a colon followed by the value for that header. And that might give us a little bit of insight into what's going on here. So let's deploy that. And we're going to be interested in the contents of this log when we run the template this time. So we'll run the client. Again, that ran through okay, but now let's inspect the console. Well, it might not be that easy to read, but there's only a couple of things that we want to get out of this. I've put a highlighter on the screen, and that's showing you the headers that have been output as a result of our first request. And very importantly, you can see there that we have the header name of authorization, and the value is our encoded username and password. A little further down, I'll move the highlighter. This is the second request that we made. And to my absolute surprise, can you see here that there is indeed a cookie that has been sent by the client with a session ID. And it's this session ID that the server is using to restore the credentials for that particular client. Now, I was amazed when I saw this because the REST template is designed to be stateless. As I say, that's the point of REST. But then it dawned on me. It's this second line of code in our REST client. I admit I had almost forgotten why this is here. We're calling template.setRequestFactory, and we're passing in an instance of a class from the Commons HTTP client library. But we did this on the original Spring Remoting course. And we did it because we wanted to support an extra type of HTTP request. We wanted to support the options verb. I don't know if you did that course or if you remember doing it, but we were effectively using a richer HTTP client to, if you like, expand the capabilities of the basic REST template. And what I didn't know at the time, this Apache Commons client class does maintain sessions. It does work with cookies. So it's this line here that's the culprit. And if we don't want that HTTP options verb, then actually we don't need that line of code at all. If I take that line of code out and run the client again, then we get the output that I expected. We can see that the first one, the authenticated one, succeeded, but the second one failed with unauthorized, which is exactly what we wanted in the first place. Now, we won't be able to see the headers for that second request in the log because we weren't authorized, so therefore it didn't even run the controller. So I know this may feel like quite a pedantic point, and it depends on how restful you are really, but I always aim to be as restful as possible. And one of the design goals, as I keep saying, of REST is to not maintain session state. So it's much better to work with this stateless template. And this should fail, and we want this to fail. All future requests should continue to send the headers with the username and password. But that does leave one final point, which is, in this instance, we are writing this client application. But what if we were allowing third parties to call our web service? They would be using anything they like to write their client code, and they might use a template which is stateful. Is there some way that we can prevent sessions being created always for our web service? And it turns out there is. And I'll demonstrate this by restoring that line of code, which, as you know now, is going to cause a session to be created. So we're back to the point where now both calls are succeeding and there's no unauthorized there. But one setting we can make on the security config for our CRM system is we can specify here inside the HTTP pattern, there is, and I'm going to do control or command space, there is a create session attribute. And the default is set to if required, which will, as it suggests, will create a session if one is required. And what that really means is if the client sends a cookie, then the server will create a session. But there are other options here. You might think never is a possible one, but that's not quite what we're looking for. Never means that Spring will not create a session, but it will make use of one if one has already been created. That's not quite what we're after, really. There's a better match, and that is the value of stateless. For requests using the URL pattern beginning with REST, there is going to be no session maintained, regardless of what the client does. So let's give that a deploy. And we'll try the client again. And this time, even though it's sending a cookie, that's fantastic. We are now getting unauthorized. So I realize this is one of those strange things where we're doing things for purity in a way here. And it does mean that it's going to be harder work for future requests because we will always have to go to the effort of including that headers object in our future requests. But that does make our application more stateful. And the real point for that digression, I'm sorry, that did go on for quite a long time, but as I said, it had me absolutely baffled, so I wanted to talk about it. But you will see on live Spring Security applications, this create sessions stateless, and now you know the reason for using it.